When we solved equations, exponential functions before, we had certain bases that we could rewrite so that they were all the same bases, right? And if the base is all the same, we should be able to solve the exponents, right? Well, what if that's not the case? What if the equation is 2 to the x equals 20? 2 to what power equals 20? Yeah, I don't know either, right? We have to have a way to solve it. So let's think about this. What if we did trial and error? Some of you guys, that's your favorite way to try to solve stuff, right? Doesn't always work out well for you, but that's okay. You know, we'll try to learn something new. But what if we solve by trial and error? Let's try to figure out to the nearest tenth. Well, what do we know? 2 to the what power equals something near 20? What is 2 to the fourth power? Is that 20? No, but it's close. Well, then maybe it's 2 to the fifth power. Maybe that's what 20 is. No? What's 2 to the fifth power? 32. So I know that 2 to, if I'm trying to figure out 2 to what power equals 20, I know it's between what? So I know it's between 4 and 5. And I can even, because it's asking me to make a guess, right? To a tenth to the nearest tenth. If I'm going to say between 4 and 5, which one is it closer to? How do you know it's closer to 4? 20 is closer to 16 than it is to 32, right? So what do you think it's going to be? Closer to 4. I heard 4.2 and I heard 4.3. Ish. Because we're guessing, right? Well, what if we could use the table on our calculator? Wouldn't that help a little bit? Maybe even give us the exact answer, right? Well, so on my calculator, I need to create a new document that is a graph, right? I'm going to create a new document that's a graph. And I want to put in 2 raised to the x power. Some days it shows up really nice, and some days it's super weird. Looks like today's going to be super weird. That's close, right? You can see that okay? Okay. So to go to the table, I go Control T, right? Well, this isn't helping me at all. Because first of all, I need to round to the nearest, what does it say? To the hundredth, right? If we're using the table, we want to go to the nearest hundredth. Well, if I'm going to the nearest hundredth, the table is not set up like I need it set up, is it? So let's go Menu and Table, and then let's edit the table settings. Well, where do I want my table to start? I mean, 0 is the option, right? But if we think smarter, where do I want my table to start? Why would 4 be a good place for it to start? We know it's between 4 and 5, and we said it's closer to 4, didn't we? Okay. Now, how do I want my table to count? Point 1 is tenth, so 0.01. Got it? And then I'm going to hit OK. Now, what am I looking for on this table? 20. 17, now I'm at 18. Oh, 19, it's getting close. Dang it. Why are we saying dang it again? This is not 20, right? What's it doing? It's mad. Okay. It's not 20. Did I get close to 20? Yeah, but not 20, right? So let's copy down my table. Let's give X and Y. Let's do 4.31, 4.32, 4.33, and 4.34. Let's do those values, okay? So 4.31 is 19.84. Is that what you got? What is 4.32? 19.97. Is that rounded? Okay. What about 4.33? 20.11. Okay, what about 4.34? 2.5? So now we guessed 2.2, or sorry, 4.2 and or 4.3, right? What does it turn out as the answer? Well, we don't know yet, right? But what is it between this time? 4.32 and 4.33 is where it's between, right? Now, is it closer to 4.32 or is it closer to 4.33? Right? It's only 300ths away here and it's 1100ths away here, right? Okay, so it's closer to 4.32, but I still don't have my answer, do I? Okay. Well, what if I graphed it, right? What if I made the table go away, Control T, and just looked at the graph? And what if I came up here, double click that and made it be 25 instead? Well, the reason I want it to 25 instead is because I hit tab and then I entered 20. Why would I do that? If this is 2 to the x and this is 20, what am I looking for? Where they are equal, right? Where they intersect. Okay, can I do that on this calculator? Do you remember the keystrokes? Menu, analyze, intersection, right? And then I have to move my little dotted line to the left side of the intersection and the right side of the intersection. And this is going to tell me the answer, right? Well, I don't know any more than I knew before, right? I knew it was around 4.32, didn't I? But what did the calculator do? It rounded. Okay, it rounded. Okay, so my graph looks like this. That's the point of 4.32 and 20, which doesn't tell me any more than my table did, does it? Gosh, I wish there was a way to solve this algebraically. Huh? Good. Good, good. So when I say it that way, what does that mean? Yeah, there's a way, right? Okay. I need you to think about some stuff for me real quick. If the operation we're talking about is adding 4, and the equation looks like n plus 4 equals a, how do I solve for n? Right, because I'm looking for a way to undo my exponents. Let's see if I can figure it out like logically, right? If I subtract 4 from both sides, I get n equals a minus 4. How did I undo adding 4? I subtracted 4, right? What if I'm multiplying by 3 and it looks like 3n equals a? How do I undo 3? I divide by 3, so I get a over 3. So to undo multiplying by 3, I divide by 3. Well, what's happening here? N squared equals a. We're squaring, right? We're squaring n. How do I undo that squared? Now, please remember, if I put the square root in the problem, what do I also have to put in the answer? Plus or minus, right? Don't forget that. Okay. But I have plus or minus the square root of a, correct? So how did I undo a squared? Square root. So this is the problem, right? 2 to the x equals 20. That's our problem, isn't it? We have to have a way to undo exponents. And the way we undo exponents is by using logarithms. And if you don't know how to spell logarithms, it for some reason printed right there, which is also the word that goes in this blank. And here's what it looks like. We'll talk more about that in just a second, so just write it down for now. What I do want you to note is this 2 is smaller and lower. Does that make sense? In computers, what is that called? Subscript, right? Okay, so 2 is a subscript of log. You okay so far? Ready to go on? The way that adding and subtracting are related, the way that multiplying and dividing are related, the way that square rooting and square roots are related, the way that cubing and cube roots are related. Do you remember what all those are, how they're all related? They are inverses of each other. How can we generate the logarithmic graph if I have the exponential graph? How do you find inverses? How do you find it? Switch x and y. Now, when it was an equation, we switch x and y and solve for y, right? But when it's a table, what do we have to do? Literally just switch x and y. So if it was x before, it's going to be a y now. And if it was a y before, it's going to be an x now. Does that make sense? You remember that, right? We talked about inverses already. So if I go to graph this function, I have 0.25 and -2. I have 0.5 and -1. I have 1 and 0. I have 2 and 1. I have 4 and 2. And I have 8 and 3. Because I switched x and y, I kind of made them like trade places with each other, right? Do you remember that inverse functions reflect across a specific line? Do you remember what that line is? Y equals x, right? Because that's what I did. I made y equals x and I made x equal y, right? That's what I did by switching x and y, isn't it? So if I folded this paper along the line y equal x, what would be true about these two functions? They'd be right on top of each other, wouldn't they? After the fold, okay? This is a big deal, okay? Probably tomorrow when you come in, I'm going to ask you, how are exponents and logarithms related? And you're going to say, they're inverses. Oh no, you know what I mean. Next time we have class together, yes? I'm going to ask you how they're related, and you're going to tell me they're inverses, okay? And when you know they're inverses, you know they're closely related, and that's important, okay? Now, I don't want to freak you out, but the definition of a logarithm is one of the most important things you will learn in this entire chapter. Like one of the most important things that you learn in this entire chapter, okay? And it's on the very first day, and we're going to practice it a lot because it's one of the most important things, okay? So let's get it now so we don't have to worry about it later. Is that fair? If we have b to the x equal a, this is called exponential form. I need you to be able to write it in a logarithmic form. So here's how it goes. Log base b of a equals x. Well, what's this called in exponent form? What's the b called? It's called the base, isn't it? It's the base of the exponent. Well, guess what it's called here? It's the base, and guess what letter we chose to represent it with? A b. Will that help you remember where it goes? Hopefully. Of a, this is called the argument. Any idea why? I don't have one either. I have no idea why they call it the argument. That's just what it's called. Okay? I mean, you guys are familiar with arguments, so you argue with me all the time. Just a little joke. And then what's this called over here? The exponent, right? Over here, it's called the answer. But we're going to write exponent. Because that's where the exponent goes. It goes as the answer. Does that make sense? Now, how do you read this? For the record, we do not say log little baby b lower than log of a, right? We don't say that. We say log base b of a equals x. Log base b of a equals x. Now, I will tell you that some people read it another way. This is how I was taught, so this is how I read it. Okay? But some people say log of a base b equal x. Do you see how that they're the same? Yeah? Okay. Why do we use logarithms? Where's the variable? In the exponent. And do you know how to get it out of there without logs? No. So we use exponents to get the exponent, to get the variable out of the exponent. Okay, we use logarithms to get the variable out of the exponent. So let me give you some examples, okay? Because like I said, the most important part, or one of the most important parts, is the definition, and I need you to be able to go back and forth between exponential form, which is what this is, and logarithmic form, which is what this is. Okay? I need you to be able to go back and forth between these two, because that's going to help us solve some of the stuff we need to solve. Okay? So, 7 squared equals 49. Do you understand? Is it clear to you that that is exponential form? Because why? How do you know for sure that's exponential form? It's got an exponent, right? Okay. I want that to be in logarithmic form. I want you to rewrite that into logarithmic form. So first I need to write log, right? Log of what? Sorry, log base what? Yeah, what's the base over here? 7, so that's the base right here. And it is smaller and lower, but we just don't say log smaller 7 lower or something like that, right? It would sound silly, and I would probably make fun of you inside of my head, not out loud, but probably a little. Okay? Of what? Of 49 equals what? 2. Can you go from exponential form to logarithmic form? Yes? Can you go the other way? What if it's in the logarithmic form? Can you go to exponential form? Well, what's the base here? Then that's the base here. What's the answer? Then that is the exponent, and it's going to equal the argument, 64. You know how sometimes when we do a lesson, I mostly want you to be able to get like 70% like confident about our lesson, right? I want you to be able to like pass, quote unquote, right? Guys, when we're done with this lesson today, I need you 100% confident. 100% confident that you can go from exponential form to logarithmic form or from logarithmic form to exponential form. Does that make sense? Like it's that important. Before we go on though, we need to talk about 2 different other kinds of bases. Okay, I only gave you problems on one today. We'll have problems on the other later on. But the first type of base is the common log. Okay, for example, this variable right here, what's the coefficient on that variable? 1. Why didn't I write it? It's the most common, right? I don't have to write it because it's the most common. What's the exponent on this variable? Also 1, most common, so I don't have to write it, right? The common log has a base of 10. And it's called the common log because it's the most common, right? And when it's the most common, I don't always have to write it. See how right here it just says log of 100 equals 2? How would I rewrite that into exponential form? What's the base? Even though it's not written, you know it's 10, right? So 10 raised to what power? 2 equals 100. Now here's the deal, guys, about especially going from logarithmic to exponential form. If there's no variables, you should be able to tell if the answer is right before you even go on to the next one. Because think about it, isn't 10 squared equal 100? If you accidentally put stuff in the wrong place, is 10 to the 100th power equal to 2? No. Is 2 to the 10th power equal 100? No. Is 2 to the 100th power equals 10? Right? There's no other combination in this particular example. There's no other combination that would make this a true statement except for this. Does that make sense? Okay. So your homework this evening / tomorrow before class. Oh, yeah, you're right. None of you ever do your homework right before class, right? Sorry, I didn't mean to be so offensive. Okay. The A through N is what I'll be checking when we meet next time. Does that make sense? A through N. Now, obviously, I did A and H and K, so you're not going to get credit for those problems, but I'm going to be checking all of the rest of them. Does that make sense? Any questions?